So welcome everyone. As you're joining the session, then you're welcome to enter your river. It could be a river that's nearby or one that has some meaning to you. Just trying to see where all the participants are coming from and what some of these river names can be. We've already got a couple. So you can see a couple from Sweden even. Oh, Nepal. Wow, welcome. So we'll start off in just a minute. I think we'll give you another minute or two to enter your river, and then we'll get started. Wow, I have never heard of some of these. I'm gonna have to look them up afterwards, see where they are. The test of our geography. Again, if you're just joining, go ahead and scan the QR code and enter the name of a river that is nearby where you live or just has some meaning to you. Let's see what kind of river names we can collect here. Welcome. What an amazing collection. Look at that. Great. So I think we'll give it another 30 seconds or so. So if you're just joining, go ahead and enter the name of your river. So a river that is nearby or has some meaning to you. We'll see what we can collect before we get going. Already it's, yeah, the Nile, of course. We have to include that one. Perfect. So yeah, just go ahead and scan the QR code and it'll give you an option to enter the name there. And once you submit it, then it'll appear on the screen in real time. I want to make sure that we get as nice and broad of a collection as we can. Okay, well, I think that we can probably wrap it up, maybe another 15 seconds or so. Thank you so much, everyone, for taking a moment to do that. I think it's quite interesting and neat to see where what everyone's thinking when it comes to rivers. Great. So thanks again. Hello and welcome to this online session on healthy rivers and streams. We hope you are enjoying Stockholm World Water Week. It's great to see water and public health professionals, scientists, and environmental engineers coming together each year to solve problems together. It's as co-creators that we will make a difference. So we'll start with the agenda for our 1 hour session together. We're going to talk about the speakers and make a little bit of an introduction so you know who is speaking. Then we'll talk about the state of our rivers, what has happened in the UK with public pressure to stop sewage spills, and the lessons we can learn from there. And then we'll delve into the issue of urban runoff. Finally, we'll talk about what can be done through better management of wastewater systems and technology we have today. We'll tackle as many questions as we can during the Q&A session, but feel free to enter your questions in the chat. You can either direct them to a specific speaker or you can enter them for everyone to see, and I will moderate at the end. So with us today, we have Karen Novak, civil and environmental engineer with a background in water resources management. We also have Rebecca Willey in civil engineering, specializing in water and wastewater network design. Joe Bradley is the founder of Stormwater Shepherds and is our co-presenter. Welcome, Joe. Stormwater Shepherds is a charitable organization in the UK with the goal to raise awareness of the impact of human activities on water quality. She is a zero pollution ambassador, and that is why we are here today, pollution prevention. I'm Barbara Maslin. I will serve as the session moderator. Next slide. So to set the stage, let me start with why we're all here. Rivers are important. Our civilizations have been built upon them. They give us water, serve as transportation, and as a source of food. Rivers are iconic. The Thames, the Nile, we talked about it, the Ganges. They provide a sense of place. We need to keep them healthy, and we are trying. The Olympics swimming in Paris is an example, although that took 1.4 billion euros of investment and was still overwhelmed by stormwater. This is the goal: urban rivers healthy enough to swim in and to support nature. So what we want you to take away from this session today are ideas about how we can work towards this goal. And now I'll pass it over to Karen to continue.
Okay, so first of all, what does Autodesk have to do with water? You probably know of Autodesk as engineering design software, AutoCAD, but we actually do a lot more. We provide engineers with software solutions that cover each phase of the water cycle. That's from managing source waters, modeling flood, designing drainage for both sustainable drainage systems and traditional pipe networks, modeling water distribution systems and wastewater systems, and of course, design and optimization of treatment plants for drinking water or wastewater. So the focus for today is storm, sewer, and floodwater management with an integrated catchment management approach. And Rebecca will have a demo for you at the end to show you how you can use hydraulic models to help prevent pollution for our rivers and streams. So rivers in crisis. In Europe, we have the Water Framework Directive, which has been in place for about 25 years. And we've known for a while that improvement in river health has stalled over about the past decade. Since this legislation was implemented, we've had population growth, increased urbanization, and climate change. And what that means for water is more people. So that means more demand on water supplies and more wastewater being produced. So urbanization means more paved areas. So that means there's less area for rainfall to sink into the ground. So instead it picks up pollutants as runoff. And of course, we have the impact of climate change, more frequent and more intense rainfall, so pollution can happen more often. So this whole combination means we need to rethink how we manage stormwater. And that's to protect the environment, to ensure we have a good supply of clean water, and to support both people and nature. So how do we know that rivers are struggling? Well, back in 2022, this map was published, and that pretty much summarized the results of river basin monitoring for the WFD. And this EU legislation requires member states to work towards achieving good status in all bodies of surface water by 2027 and groundwater. Good status is a combination of ecological and chemical parameters, and there's concern that those just aren't improving anymore. So how do we measure good? What does good mean? Well, it's the presence of aquatic life, invertebrates, fish, a river's evidence to support an ecosystem. It's nutrients. Is there excess nitrogen or phosphorus? Physical chemical parameters like pH, dissolved oxygen, temperature, and increasingly contaminants of concern, pesticides, herbicides, heavy metals. And that's where our rivers tend to be struggling. We have chemicals that are persistent and will take decades to break down. This is a quote from the UK Environmental Audit Committee. The problem's acknowledged. If we focus here on England, there's been about a 4% deterioration, and no river here achieves good chemical status. So there's an acknowledged pollution problem, and it's comes from a combination of wastewater, urban runoff, agriculture, industry. And here, phosphorus is considered the biggest contributor. So it's excess nutrients. The achievement of good chemical status has been extended to 2063, and that's primarily because of certain ubiquitous persistent chemicals that are going to take a while to break down. But it's sewage that tends to be at the top of the agenda. And if you live here, you'll have seen reports of raw sewage spilling into rivers and seas, resulting media coverage, and even political pressure. In the last election, the government lost some seats in regions where sewage was a high-profile issue. And part of this issue is due to older combined systems. And this is where you have CSOs. The pipes are used to carry both wastewater from homes and also stormwater drainage. And this is how it's played out over the past 5 years in the media. So first in 2019, a water company admitted sewage discharges and received a record-breaking fine for pollution. In 2022, we had COVID and people were unable to travel. And so they started open water swimming and they started asking, is it safe to swim? The Environment Agency implemented some real-time spill monitoring and storm overflows. And now this data is made available to the public. And the result is that the public knows when this is happening and it's not acceptable. And it becomes a political issue. And even with the monitoring, the situation hasn't improved. All of the wastewater utilities are under investigation by the industry regulator. And of course, dog owners are concerned. So why does this happen? Years ago, when wastewater systems were designed, engineers thought it would be efficient to use the same pipes for both the stormwater and drainage and for the sewer network. And it was sized that way to handle both, but with population growth and changing storm intensity, it's become more problematic. So on the left, the system's working correctly. All the wastewater flows through the network to a treatment plant. On the right, it's raining hard and the stormwater is overloading the network and it has to go somewhere or to back up into the house. So a combination of rainwater and raw sewage is released through the mine sewer overflow into the river. This is a photo of a CSO discharging, and it's no longer an acceptable situation, but for years it hadn't necessarily been illegal, and sometimes it's consented. So some of the impacts are fish kills due to oxygen depletion, eutrophication due to excess nutrients, phosphorus and nitrogen, and of course, public health risk due to pathogens and sewage. So how big is the problem? There are over 20,000 CSOs in England, and all companies need to publish data from event duration monitors installed at the CSO. So now we know that spills are happening. The sensors tell us where, when, and how long they happen, but they don't really tell us why, and that's the challenge that the industry is facing. So what can we do to fix this? Change is happening, and policy and regulation will play a role. In the UK, we have intense political pressure on water companies to invest in pollution prevention during the upcoming asset management program cycle, and it's the 5-year funding round. And in the EU, we have the Urban Wastewater Treatment Directive, which is being updated this year. So in England, each wastewater utility has a storm overflow discharge reduction plan. So monitoring's in place and spills are being reported. Each utility also has a drainage management plan to show how surface water is managed to reduce the risk of overloading the sewer system. And then there's the record investment that's going towards pollution prevention. Over the next 5 years, the water utilities expect to spend about 88 billion upgrading their infrastructure, and about 10 billion is going to go towards pollution prevention. And that will also include river water quality monitoring. So in the EU, the approach is slightly different. It's preventative catchment-based approach towards pollution. And to help get rivers to good, the EU Urban Wastewater Treatment Directive is being updated now for the first time in 30 years. And this was a landmark piece of legislation when it first came in because it created a step change in water quality by setting standards for wastewater effluent. And the challenges are different now, and the revisions are going to address new ones like micropollutants, energy neutrality, and greenhouse gas emissions. And importantly, it also acknowledges that CSOs are a problem and includes a new obligation for integrated urban wastewater management plans to combat pollution from stormwater. That's a combination of urban runoff and CSOs. So an integrated urban wastewater management plan is going to be needed for catchments in Europe with more than 100,000 people, and for those with more than 10,000 in areas that are environmentally sensitive. So the idea is to look at the entire catchment and assess the impacts of storms on drainage and sewer networks, and to understand what the pollution risks are. And this is important, particularly where you have combined systems, because that's where you have the highest risk. And there's also an expectation that nature-based solutions and digitalization are going to be prioritized over your traditional concrete storage structures. This is sustainable drainage and the sponge city concept that we can see in places like Berlin and Amsterdam. And here are some photos that just show swales and rain gardens. These are actually engineered structures for drainage. They'll have under drains and different media for filtration. And they are sustainable drainage features, which will allow water to sink back into the ground near to where it falls, instead of treating it as a waste product to be piped away. Jo is going to have a little bit more examples of these in her presentation, and I will turn over to Jo Bradley from the Stormwater Shepherds.
Thank you, Karen. Thank you very much. And hello, everybody. My name's Jo, and I work for a little charity called Stormwater Shepherds. I work in the UK, and I focus very much on reducing pollution from urban surfaces. Next slide, please, Karen. Thank you. So I'm going to talk today about pollution from highway runoff. So this is, we know that highway runoff causes pollution. There's about 30 years or more of research globally looking at pollution from highway runoff. Some of that done in the UK, but a lot of it done in Australia and elsewhere, showing that highway runoff contains different pollutants and causes different types of harm. This is a little pipe. Sorry, Karen. That photograph is a little pipe that discharges off a very busy motorway in Cheshire in England and goes into a tiny little stream called Massey Brook. And I will show you some results for that outfall shortly. Thank you, Karen. So the pollutants in highway runoff are, there's lots of them. Probably the biggest one is the suspended solids. So if you measure a sample of highway runoff, you'll find that the suspended solids level will be as much as 700 milligrams per litre or sometimes more. And within those suspended solids, there are lots of different pollutants that have different effects on the water environment. The ones we concern ourselves with most of the time are the toxic metals, particularly copper and zinc, because they are toxic to the creatures that live in the river, but they're also toxic to the whole food chain. So everything that eats the insects and then the fish, that those toxic metals pass up the food chain. There are also microplastic tire wear particles, as these ones in the image show you. These are tiny microscopic particles mostly, and they come from the abrasion of tires when you're driving on the road, but they leach out toxic pollutants. They also carry toxic pollutants into organisms when they're eaten, and also they, just as a physical pollutant, creatures will eat them and they fill their stomachs up, so the creature thinks it's full and doesn't therefore get enough nourishing food because its stomach is filled with microplastic tire wear particles. The other pollutant I spend most of my working life talking about is polyaromatic hydrocarbons. And these are hydrocarbon derivatives that come from exhaust emissions landing on the road surface, but also unspent fuel coming out of the exhaust, and also from tire manufacture as well. And polyaromatic hydrocarbons are carcinogenic, mutagenic, and tetragenic. So they have all sorts of harmful effects on the creatures living in the river. They cause endocrine disruption, they cause mutations, they cause deformities in the creatures, sometimes at the embryonic stage. So by the time the creatures are hatched or born, they're already deformed, but also the pollutants affect their behavior. So they can't escape from predators, they can't find their own food. And so this cocktail of pollution affects the creatures living in the river and means that they can't thrive or grow, and the population is lower than it should be, and the individuals are less healthy than they should be. And that has a knock-on effect on the whole ecosystem, because the river flies that live in the river in their larval stage should then hatch into the environment and become food for bats and birds and other creatures. And so by suppressing the health of the population of the creatures in the river, you affect the river health, but you also affect the broader biodiversity. There are also risks to human health, which I won't talk about in detail today, but there are also definitely risks to human health. Thank you, Karen. So we've recently, myself, Stormwater Shepherds and some colleagues at SIWEM in the UK, recently published this report funded by the Rhys Jeffreys Road Fund, which contains a lot more detail about what we're talking about. And I will put the link in the chat for you to download it. Thank you, Karen. So why do I worry about this pollution? Why does it keep me awake at night? It's an incredibly widespread pollution. In England, we've got 25,000 discharges just off our trunk roads and motorways, discharging into the water environment from pipes like that one shown in the photograph. But we think there are probably 1 million discharges off all the roads. So residential roads, roads in towns and cities, rural roads around the countryside. Every road will have discharges of highway runoff into the environment, and we think there are 1 million of them across the UK. So for all the countries you're working in, there will be discharges of highway runoff when it rains going into your water environment too. And some of you will have more regulated control of those discharges than we do in the UK, and some of you may have less. And so it is a global problem as well as a local problem for me. Most of the ones in the UK discharge into rivers or streams like this one, but some of them will go to ground, and I'll show you a photograph of that in a second. Next slide, please, Karen. So this photograph is of a little drainage ditch alongside a motorway in a town just north of a town called Portsmouth. And this is on the chalk horizon. So I don't know if any of you live in countries where you have chalk aquifers and chalk horizons, but this discharge goes straight into that chalk aquifer. And so there's no treatment at all. And we have no idea of the extent of pollution that runoff is causing to the aquifer. We have no monitoring in place. There's very little research, and that discharge happens every time it rains, carrying those pollutants we've just described into the chalk, the unsaturated zone of the chalk, and then ultimately into the aquifer beneath. And so that sort of structure is something that needs far more research and needs far more control, I think. Next slide, please, Karen. One of the biggest problems for us in the UK, and actually I think across most European countries as well, is that we don't have enough monitoring of this pollution. And so the Water Framework Directive describes controls for some of the pollutants that are in highway runoff, but nobody's monitoring to see whether or not the discharges are complying with those controls. So in the UK, in England particularly, the environmental regulator doesn't have any specific monitoring points to measure this particular pollution source. So there are no monitoring points located immediately downstream of highway discharges specifically to measure that pollution. The other problem is that the regulators don't routinely measure for polyaromatic hydrocarbons when they take river samples. So even if this pollution is a problem, they don't measure it. So they wouldn't know even if it was happening. The third problem is that most of the Water Framework Directive classification points are at the bottom of the river catchment. And so any pollution that's occurring further up the river catchment isn't measured at the monitoring point because it will have been dissipated and diluted. That doesn't make it acceptable. It just means that at that point in the river, it's not causing harm, but it will cause harm at the point of discharge. So that failure to measure in the right place is a massive problem. And the fourth problem is that this pollution only occurs when it's raining. And so if you don't sample in the rain, you will not catch this pollution and the effects of it on the water environment. So there are lots of reasons why we're not measuring this pollution properly. Next slide, please, Karen. So just, I shan't labour this slide, but the details of this slide are in that report that I will provide the link for. These were the results that I took of that first image I showed you, that little pipe coming off the motorway and going into a little stream. And in the fourth column, you can see the maximum allowable concentrations from the Environmental Quality Standards Directive. So concentrations like that are applied across Europe and must be pursued. Compliance with those standards must be pursued by the regulator. That is one of their statutory duties. So the sample I took, you can see from the third column, failed to meet or to satisfy the environmental quality standards for those 5 pollutants, they're polyaromatic hydrocarbons. So for those 5 polyaromatic hydrocarbons, the discharge was causing a failure of the environmental quality standard. And so that discharge needs to be treated. Next slide, please, Karen. And so how do we treat these things? It's all very well saying it's a massive problem and it's widespread across the globe. We need to understand how to fix it. For low traffic and medium traffic roads, so roads with traffic levels of about 15, anything up to about 15 or 30,000 vehicles a day, then sustainable drainage devices or low impact devices like these are acceptable and in fact are fantastic. So this is a rain garden in a city called Sheffield. And this rain garden is beautiful and it's full of flowers at the moment. It's a really lovely place to be. The road runoff from that road where that blue car is just comes straight into the rain garden, just over a flat curbstone. And within that rain garden, you've got a depth of soil, you've got a couple of meters of soil. The soil has been specified very carefully to capture those pollutants. The suspended solids will be captured at the surface. The organic pollutants will be broken down by the microorganisms in the soil. And all the natural processes of sunshine and the plant uptake of nutrients and the microorganic activity in the soil will break down that pollution. And so they are an excellent solution for pollution from road runoff where the traffic isn't too bad. Next slide, please, Karen. And this is another alternative for low and medium trafficked roads. This is called a swale, and Karen showed us an image of a swale before. This was not designed as a bioswale. This is just a normal swale that they've stopped mowing. So it's become a beautiful bushy bioswale, and it's got reeds and grasses, but it's also got some irises in there. It's become a really lovely habitat. But again, the pollutants from that road surface when it rains run straight into that swale, and all those natural processes take place again, take up the pollutants, break down the organic pollution, and create a really lovely sustainable drainage device like that. And that's quite easy to maintain. The local authority, they just trim a little bit at the edge of the swale through the summer, and then in the winter they come and they mow it properly and take that material away. So not particularly difficult maintenance. Just click again, Karen, there's another image. So this is one of the suds in Sheffield that I showed you a second ago, and this is one of them being built at the moment. So they're building some more at the moment. And you can just see from that image that they are relatively straightforward to construct and design. The trick is to get your soil specification right. And Sheffield, the team in Sheffield have done a great deal of work on their soil specification, and they've got it, I think they've got it bob on now. Next slide, please, Karen. If you're working with busy roads, so trunk roads, motorways, autobahns, all sorts of busy roads around the world with a traffic density of more than 30,000 annual average daily traffic, so that's the number of vehicles moving, then the pollutant load may be too high for those sustainable drainage systems to cope with. You can imagine you're talking about, all of a sudden you're talking about 400 or 500 milligrams per litre of suspended solids every time it rains, maybe as much as 1,000 milligrams of suspended solids in heavy rain, huge levels of copper, zinc, polyaromatic hydrocarbons, microplastic tire wear particles. You can't put that straight into a sustainable drainage system and expect nature to cope with it. It's too much. So for busy roads like that, we ask for a sediment removal device at the top of the drainage network. So this is a vortex grit separator. You can also have sediment capture devices and potentially sediment forebays, and they capture maybe half of that suspended solids before it goes forward into the next treatment device. So these are essential for those heavy pollutant, highly trafficked roads. Next slide, please, Karen. So once you've done that and you've used your gross pollution device to capture most of the suspended solids, then you go onto a vegetative device like this pond. This is a newly constructed pond in a town called Congleton, and it takes the runoff from that road where you can see that lorry in the background. So these devices, it can be a pond or a basin or a wetland, they then let those natural processes take place. So again, you get sedimentation, precipitations, assimilation, you get volatilization into the atmosphere, but also the sunshine plays its part and all the microorganisms play their part. So lots and lots of natural processes going on in that pond to clean up more of that pollution. And if you get it right, then that can become a habitat for wildlife as well. So you need to make sure it's clean enough, but it can also be a habitat for wildlife. The other thing we ask for when you build a pond like that is a closure device on the outlet, so that in the event of a massive spill on the motorway or a fire on the motorway, then there's somewhere to capture that pollution to protect the further environment. So you can put a closure device at the inlet to your pond or the outlet from your pond, depending on your design, but it gives you then the freedom to capture pollution and deal with it properly in the future. Next slide, please, Karen. And then the last point to make really on design is this importance of making sure that what you design is healthy. So when you design a treatment pond or a basin or a wetland, you're creating a habitat that you hope small mammals will move into, or insects will lay their eggs in, and small creatures will live in. And you need to make sure it's sufficiently clean for that to happen. And so good design, this is another little pond on a road in Lancashire, and good design of a pond like that can create a really nice habitat for wildlife. Sometimes, if that pond is discharging into a stream which is really, really sensitive because it's a chalk stream, or it's got pearl mussels living in it, or it's got white-clawed crayfish living in it, there's some reason why that's a really, really sensitive environment, then you may need tertiary treatment downstream of your pond. And to be honest, we don't use a lot of tertiary treatment in the UK at the moment, but that would be something like a stormwater filter or a biochar filter perhaps, and that would just take out that a little bit more pollution before it goes into the river. Thank you, Karen. And then whatever you do, you need to maintain it. So people put these devices in. In fact, literally this morning, I had a conversation with a gentleman from Australia who said that there isn't enough maintenance in Australia for these devices. And certainly in the UK, there isn't enough maintenance for these devices. If you put these devices in, like this sediment capture device here, you have to maintain them. And if your ponds, your basins, your wetlands, your swales, you have to maintain them, because we're asking these devices to manage this huge pollutant load and to protect the environment. And to do that, they have to have the maintenance they require. Because of that, one of the most important design considerations you must have is who's going to pay for the maintenance of my design when I've built it. So there's no point designing a beautiful treatment scheme with a vortex grit separator and a lovely pond and maybe a tertiary treatment filter to protect the river from pollution if you can't say who's going to maintain that forever and who's going to pay for that maintenance. That's the most important thing. Where is the money coming from? Next slide, please, Karen. And don't believe that vegetative devices don't need any maintenance. Sometimes people will say, oh, suds are great because we don't need to look after them. But you do need to look after your suds. You need to litter pick, as this gentleman is here, but you also need to mow them off, particularly in the winter, to take away some of the vegetative material. And sometimes you may need to go in and scrape off the top layer of soil and put new soil on. So don't be fooled into thinking that sustainable drainage systems don't need maintenance. Next slide, please, Karen. And this is I love this slide because I think it's really a really good visual interpretation of that. The photograph on the left is the sediment that we removed from a vortex grit separator in a little town called Wigan. And this was on its way to the treatment plant. So we'd sucked it out of the vortex grit separator with a vacuum tanker, and we were taking it away to be treated. And this was the first phase of treatment. But if we removed about 4 tons of that sediment from one outfall in one town. So if you multiply that up across all the towns across England and then the UK and then Europe and then the world, there is a massive, massive amount of this toxic sludge coming off our highways and going into our rivers. If we hadn't installed that treatment device, that sludge would have gone into the river. And we know it's toxic because we've already measured the toxicity of highway runoff. So we know it's causing harm to the water environment. And that's why these treatment schemes are so important. The image on the right is an oil water separator that's just about to be emptied. And the reason I show this slide is because it just shows how effective that device has been to capture a huge volume of that sludge and keep it out of the water environment. So these devices are brilliant, but they need to be maintained. Next slide, please, Karen. So just to finish, remember that if you get the design of these treatment systems right, then they can create a really pretty habitat like this one here that Alistair took a photograph of in London. So don't despair. Highway runoff is a big problem, but we have the solutions and the solutions can be beautiful. Thank you.
Right, thank you, Jo. Okay, next I think we have Rebecca with integrated catchment modeling.
Yes, thank you. Thanks, Joe. Yeah, just a reminder, if you have any questions for Joe or Karen so far, to pop them in the chat, and we'll come to those at the end of my section, so just in a short time. So yeah, what I'm going to look at now is some of the technology that's used throughout the world to help design and understand some of these problems, and ways that they can be designed to eliminate them. So whether that be understanding the root cause of where some pollution might be coming from, and then to design against and to be reducing that. So as we go through, you can see on the screen here, this is infradrainage. This is one of our solutions that helps optimize design for new and retrofitting pipelines and sustainable drainage. So as Joe touched upon, with the schemes that she had, the sustainable drainage element is an element that is becoming more and more required and important as part of the designs. And so we can see here the designing of some swales to go and connect with the pipe and manhole design. So we have templates to help this process be much quicker and easier. And you can really quickly get to a preliminary design and a preliminary layout of your plan, simply by editing and re-looking kind of at your network. And because of the CAD imagery and backgrounds, you're able to understand that full site design. So whether that be how you're fitting in with a new housing estate, so you may have other elements involved there, or just understanding the surrounding environment and topography. Next slide, please, Karen. And then again, what's very important is understanding that hydraulic analysis and representation. So what we do want to make sure is how the water is going to pass through these structures, that we have that we've taken into consideration for different levels of filtering and the effects of these structures slowing down flows. What we don't want to do by installing these is to be causing flooding to, for example, in this a new housing estate. So we have our plan here that you can see. And so we need to make sure that our analysis is ensuring that we aren't having a detriment to the downstream network, and that we have made the network sufficient. So we have the optimized tooling for the sizing of all your pipe work. And then with long section views, like you can see here, you can see the levels of those substructures when thresholds are being met at different storm events that you can click through to understand the capacity and when that capacity is being exceeded, or you're having or you have a flood risk. And then that's shown, as you can see, in the long section, but then also again in the plan view, so you can see that within your site, and whether that's going to be causing an issue to other parts of your network, and maybe you need to move some of those structures or redesign some of the pipe network to be able to cope with that. Next slide, please, Karen. And so once we have this understanding of a new or existing infrastructure, pipes, manholes, and these substructures, to understand their impact, to make sure they are removing some of the water that will then end up in the river, as well as helping with the water quality aspect, again, that Joe was speaking about with some of those rain gardens. We then want to be able to move this and understand this at a larger scale. So to make sure that this isn't impacting the whole catchment. And Karen spoke about the urban wastewater management plans and the whole catchment understanding of that. So we have the ability for this data with InfoDrainage to be moved into Civil 3D, but it can also be moved into InfoWorks ICM to understand that on a bigger scale. Next slide, please, Karen. And so InfoWorks ICM is a solution that helps you understand your whole catchment. So you have a fully integrated river, tidal, underground assets, the surface. Did you click? If you go back a slide, Karen. I think we maybe missed a video. That you're able to see. Yeah, you're able to see this larger catchment, the elevations, the topography, and understand the interactions between multiple elements, and how the water quality is affecting that, whether you have the water quality, for example, as we have discussed, coming off the roads and into the rivers, or whether we're looking at fluvial water quality and the suspended solids, dissolved oxygen, different elements. So we can have a full understanding of large rivers and their interaction with the urban environment. So we can see here that we have a quite rural catchment at the start, and it's going into more of an urban environment, and then it is going into the sea in this instance. So next slide, please, Karen, and you'll just be able to see that in much smaller detail with this video here. So here we have the more detailed close-up kind of analysis of that. So here we're looking at the flow routing of the overland runoff. We can see that by the orange arrows of the flow direction and the velocity that's traveling down the streets. And then we can see where water is ponding, and how deep that is, and where that's coming from. So for flooding analysis, but also ensuring that the design that we've made of these substructures and these catchment environments, that they are sufficient and they are not causing more detriment downstream to other parts of the network. So yeah, we can see here in 3D. So here is that network that we saw larger scale. So you had that full understanding that upstream it was more rural, and here is the town lower by the beach. And we can see here by the two highlighted pipes in red that we have, that we're able to see the outfall, the outfalls into the sea. So when we're looking at pollution and understanding the levels of pollution and the levels of outfalls from CSOs into rivers or into coastal environments, this can help quantify and justify investment that might be needed to prioritize these to make more storage, but it can also just help with information as to what the current situation is, and then as we go through design scenarios, how much we have reduced those overflows and that volume into the environment. But because the solution allows you to go from the pipe network to the overland and understanding how water is flowing over the surface, we can see here where that overflow, where that water is going. and how that's traveling to the sea, how long that's taking to enter different points of the river and different detection points. Next slide, please, Karen. Yeah, just, I don't know if there's more point, if you just click through the screen. And so, as I said, to be able to mitigate against that, there are multiple design options and scenarios that can be developed. So the solution allows us to plan for those and do some quick designs for the whole catchment, which can be really useful when, as Karen was explaining again about the wastewater management plans and how we can manage water better. There are ways for us to look at those options within the solution in order to get the best solution. So we can be comparing the traditional solutions as well as the SUDS solutions and combinations of those as well, to ensure that we're not having detriment to flooding and we're not having detriment towards quality and pollution for our rivers and the environment. I think, is that next slide, please, Karen?
Thank you,
Okay,
Rebecca.
perfect.
Okay, so in summary, let's clean up our rivers. So river health is at risk. Sewage discharges are only part of the problem, and we need to monitor, operate, and maintain our drainage infrastructure effectively. And that includes our highway drainage infrastructure, a significant source of pollution. And as Rebecca just showed, we have hydraulic modeling tools which can help you design and deliver improvements. Okay, so back to Barbara.
All right, thanks. I actually saw some fantastic questions coming in through the chat, so I will address them in no particular order, but in hopefully an order that makes sense. So starting from one of the earlier ones, I think this one's probably maybe intended for Joe. What happens to the toxic sludge and how is it processed and where? I think that's quite an interesting question.
Oh, Barbara, it's a question with the wrong answer, I'm afraid. At the moment, in the UK, that sludge is treated to make it less hazardous, and then it goes to landfill. Because of the mixture of pollutants within it, it's really difficult to find a use for that sludge at the end of life. There have been research programs where they've tried to take the inorganic sort of solids and use them in building block manufacture and similar, but frankly it's really difficult to handle, so it goes to landfill. There is also a little glimmer of hope, because the levels of palladium, platinum, rhodium, copper and zinc, I think, are quite high, and so as the prices of those precious metals go up, there is a possibility that people will choose to harvest or mine those metals out of that sludge, because it will become financially viable, but not at the moment. At the moment, it goes to landfill, I'm afraid. Sorry.
Yeah. No, I think it's important to say it out loud, right? Everyone, so everyone knows. There's a question just before, and I think I will say it, and I'm not sure we have the answer, but I think it's worth calling out. So is there a standard or guideline for companies on how to calculate the impact of their business activities on runoff water? So for example, if we're thinking about logistics companies, whose responsibility would it be to calculate that impact? And is there any way to do it?
Yeah, so in the UK, we have a thing called the SUDS manual. And within the SUDS manual, there's a little set of tables, which I have on my kitchen wall. And they allow you to identify the pollution hazard from your runoff, your stormwater runoff. And then it helps you to design a treatment scheme that mitigates that hazard. They're not explicit numbers, they are indices. But it gives you a guide as to how much pollution you can expect from different surfaces. So if you've got a distribution warehouse, for example, it will give you an indication of what pollution you can expect off your roof, what pollution you can expect off your car park, what pollution you can expect off your haulage road. And so you add that together and you can design a treatment scheme for your site based on those numbers. In other parts of the world, I know in America, they've got the best management practice database, which gives you information about pollutant loads from different surfaces. So there is information out there and you can work it out. the best thing to do is to go out in the rain and take a sample, but it does mean getting wet.
Yeah, thank you, Joe. And actually, that's a nice segue into the next question that asks whether or not the population or the density of pollutants is greater in industrial areas rather than in rural or residential. Is there any?
Yeah, yes, it is. If you're talking about the toxic pollutants I mentioned earlier this morning, but remember that in rural areas you've got a whole different sort of menu of pollutants. So you start to look at agricultural pollutants when you move into rural areas. So different land uses have different problems, which is worse and which is better. I wouldn't like to put them into a league table, but certainly for the toxic pollutants I was talking about this morning, then urban areas are the worst on busy roads. But then into rural areas, you start to, as I say, look at nutrients from agricultural runoff, but also herbicides and pesticides from rural runoff. And then you've still got the storm overflows and the sewage associated with your population densities. So different pollution from different land uses, and I wouldn't like to say which is the worst.
Fair enough. Rebecca, I think that maybe if you could clarify InfraWorks ICM and where that sits within the Autodesk portfolio. I don't know, there's a couple of questions on that, and I'm not sure how much time we want to spend on it, but maybe just clarify a little bit.
Yeah, sure. So currently both InfraWorks ICM and InfraDrainage are not included in any collections. They are separate purchased software through your normal means of purchasing Autodesk software. And they are kind of standalone software, as in they are not reliant on any other specific licensing, or you don't have to have, you know, CAD or Esri or, you know, any other solution. But yeah, they are a separate installer and software. But yeah, if you want more information, I think our emails will be on the next slide, and you can email me and I'll send you more information.
I could put that one up now.
Yeah. There we go.
Yeah.
Now, maybe I'll ask the speakers, did you get any direct questions in your chats that we should address before you didn't? Everyone was able to share for everyone. That's great. There is one more question, and that is around hydrology models depend strongly on height data map. Which sources do you use for height map data in order to ensure precision modeling? I guess that's a Rebecca question.
Yeah, I mean, it will vary throughout the world where you have access to that information. So some countries have that kind of free, kind of available to them. There are tools in the software if you just have a bit of height data. So maybe you've done some surveying on your site. We can kind of fill in the gaps using engineering judgment of, you know, if you're in close proximity to assets that do have information. So you can get started without all the necessary information. But yeah, the sources of where it's from would depend on your country.
Great. Thank you everyone for the questions. Great questions. Thank you all the speakers for taking the time and being so great at answering everything and sharing the information that you've had to share today. We did say that we had emails here, but we don't.
Oh, okay, sorry.
I wonder, maybe should we put them in the chat so they're easily accessible? If all the speakers could do that, that would be great. And in the meantime, I will share some QR codes. So if you want more information about ICM, you can scan the first one. The second one is just for students. So if you want to experiment with the technology for free and try it out on your favorite river, you can do that with the second one. And then, of course, if you want to support River Health and Joe from Stormwater Shepherds, you are welcome to scan the third QR code and contribute in whatever way you can there. So thank you. Thank you, everyone. If there are anything, we have a few minutes left. If there's any final questions, otherwise, or final words from the speakers, I will invite that as well.
Barbara, there is a question in the chat about modelling of stormwater flows, and I wonder whether it's worth pointing people in the direction of the SIWEM urban drainage modelling. Is it a SIWEM document? So we have an urban pollution management document in the UK where we manage and model urban pollution. I'll try and find a link and share it on my LinkedIn page later today. But that's a modelling tool that looks at urban catchments and the effect of those urban catchments on the receiving watercourses.
Thanks, Joe. Yeah, missed that one. So great that you pointed out. Well, if there's nothing else, I really want to thank everyone for joining today, taking the time to talk about this very important topic, I think. Thank you to all the speakers, and have a great rest of the week.
Thank you very much.
Thank you, everyone. Thank you.